This Bio 181 video for chapter 2, the key concept we're starting with is in a chemical reaction, the chemical bonds of the reactants are altered to form the product. So in a chemical reaction, you start with reactants. And then you have some sort of chemical reaction where the electrons are going to be moving around and reorganizing. And then the bonds are going to be changing, and you're going to find you have some products. So a very simple chemical reaction would be the ionization of water. So you start with molecular water, something that looks like this. If this is the chemical formula. And it could break apart where you would have hydrogen ion this and a hydroxide ion like this. So it splits apart. We have a neutral water molecule here. We have a positive hydrogen ion here and a negative hydroxide ion over here. Now, the number of atoms over here is always going to be equal to the number of atoms over here in a balanced chemical equation, right? If this is balanced. So you can see there's 2 hydrogen here on the left, and there's 1 hydrogen here, a second hydrogen over here. So yes, check. We've got 1 oxygen on the left, and check, we've got 1 oxygen on the right. So that's a simple chemical equation. Right? You can have a more complex one. We're going to have you memorize this a little bit later in the semester, but I'm going to start with it here. So let's just actually look at, why don't we look at photosynthesis? So photosynthesis, not too early to introduce this. You don't have to memorize it yet. So we're going to start off on the left. The reactants are going to be water and oxygen. Oh, sorry, water and carbon dioxide. Carbon dioxide. We're putting the words first, and then we have our chemical reaction. Chemical reaction. The electrons are going to move around, different bonds are going to form, and then we're going to have, as a product, we're going to produce sugar, which is glucose. The type of sugar, so this is sugar. There are lots of different types of sugar. Glucose is one. And then we're also going to produce as a byproduct oxygen gas. Okay. So over here on the left, these are the reactants. Over here on the right, these are the products. I could write them with a chemical formula. So I could write H2O, and I could write carbon dioxide is CO2. And then I have my arrow for my chemical reaction. Glucose is C6H12O6, and oxygen is O2. Now, for this to be balanced, I need to have the same number of atoms on the left as on the right. And so the hydrogens over here, it turns out we're going to have 6 hydrogen, 6 water molecules on the left, 6 carbon dioxide molecules, 1 molecule of glucose on the right, and 6 molecules of oxygen gas on the right. So if we were to count them up, the number of hydrogen over here on the left, we would have 6 times 2 is 12. And then over here on the right, hydrogen is only found in glucose, so there's 12 of those. So check, we've got the same number, great. Then we've got oxygen on the left. There are 6 in the water molecule, and there are 6 times 2 or 12 in the carbon dioxide molecule. So that means the oxygen that we actually have 6 plus 12 equals 18. Over here we've got oxygen. We're going to count them up. We've got 6 in the glucose, and then we've got 6 times 2, which is 12. over here in the oxygen gas. So we've got 6 plus 12 equals 18, so that's the same. The last we just want to check is carbon. So carbon on the left, we've got 6, and carbon on the right, we've got 6. So this is balanced. All right. Erase that. Why? Okay, so when an atom loses an electron, or basically, that's the most extreme example. It can also just lose energy. But generally for this course, we're going to talk about losing an electron. So if it loses an electron, it's oxidized. And if an atom or a molecule gains an electron, it's reduced. So there's a way to remember this. It's called oil rig. Oil rig. This is a mnemonic. So it's a way to remember it using these words. So this is oxidation is loss. Okay, so you lose an electron, and reduction is gain. And this is important because it's actually counterintuitive. When you reduce it, it's easy to think along the wrong line. So you just want to memorize oil rig, oxidation is loss, reduction is gain. So example here, if you have sodium, and sodium on the outer, I'm just drawing the outer valence electrons. It starts off if it's neutral with 2. Chloride over here, if it's neutral, the outer valence electrons actually have 7. Most of them are paired together. So this is, you're starting out. These are both neutral. If you were to have oxidation, oxidation is loss. So if the electron goes from sodium to the chloride, then you're going to be left with sodium, which is 1 electron on the outside, and that's going to have a net charge of +1. Okay, so this is basically a sodium ion. So sodium in this case has been oxidized. It has lost its electron. Whereas over here, chloride has gained the electrons, so Cl, right? Now it's actually going to have 8 electrons on the outside. So it's nice and happy. These atoms really like to have 8 electrons, and they're offset. They can have 8. And so this has a net charge of -1. So this chloride ion has been reduced. And now these are going to be attracted. And if you remember the bond that's going to attract sodium and chloride ion, it is an ionic bond. Okay, so an ionic bond is going to attract them together. All right. That's it for this video.